graphing quadratics. Yes, that means parabolas. What's the shape of a parabola? Show me with your arms. A U, the U looking thing. So yes, but today we're gonna graph that a little more precisely than just doing a U. So let's do a table of values. And let's go from -2 to 2. So if I plug in -2, most of us are finally okay on this. What do we get when we square -2? 4. And square -1, we get 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So 0, 0. It's 1, 1 on either side. That's basically how we'll use this in the future. 1, 1 on either side, and 2, 4 on either side, or both sides. And so today, it's still a U, it's just a little more precise because we've got some more points to help us out. The 1, 1 and the 2, 4. So most people don't memorize that whole table. Well, for one of two reasons. One is you only need 1, 1, 2, 4. The second is you don't need to memorize it, because if you did forget it, all you do is rebuild it using the same thing we did, just square some x's and basically plot some points. But most people don't even do that. They just know that a parabola is, once you find the vertex, it's 1, 1 and 2, 4 from the vertex. Well, speaking of vertex, let's think back to our transformation. That's what I'm looking for. Right 1 and up 3. So that would lead to a vertex at 1, 3. And then from 1, 3, we would use the points 1, 1 and 2, 4. Okay, let's do some together. Let's do some actual problems here. So flip it over, or wherever you find the start of this worksheet. All right, determine the transformations and graph of each function. Give the domain, range, vertex, and axis of symmetry. That's a lot of information, but once we have the graph, that information is pretty easy. So let's do the transformations first. And since we're all experts on transformations, I don't mind picking on people for transformations. So looking at number 1, Brooklyn, what's one of the things that has happened?
You go right 2.
Right 2. How did you know we went right 2?
Because of the x minus 2.
Good. X minus 2, right 2. Jordan, what else has been changed? What else is a transformation?
Goes down.
How many?
2.
How did you know that?
Because on the right there's a -2.
Good. So down 2. And lastly,
It's reflected.
how did you know that?
It's negative.
Because it's negative. Okay, so let's go right 2 and down 2. Oh, careful. This graph, or all of these graphs, they're not all centered at the origin, so just be careful about where the origin is on these graphs. So this one, the origin is like top left. That feels weird. So we're only looking at quadrant 4 here. So it's fine, just make sure you're careful about where the origin is. So right 2, down 2. Put this right there. And we're flipped if you need to like see that visually. So we're going upside down. And I'm not really even going to plot points. I'm just going to use my 1, 1, 2, 4. So from the vertex, be careful, those are not ordered pairs, right? Because they're not from the origin. They're more like ordered pairs from the vertex, which is kind of weird. But because we go from the vertex, it's always 1, 1, 2, 4. So I'm going to go over 1, down 1 on each side. Be careful with the scaling thing, right? Because the scale, the marks are every 1/2, so make sure you go over 1 and down 1. And then from the vertex again, over 2 and down 1, 2, 3, 4. Over 2, down 4. We kind of already done these. The only new part is that we're making them a little more accurate and precise by using the 1, 1, 2, 4 stuff. All right, we already have the transformation stuff. We're good on that. We know how to move things around. We know what a parabola looks like. Now, instead of just sort of freehanding a U in there, we're going to use the 1, 1, 2, 4 to make our graphs look a little bit neater. Looking at number 2, Laylo, on number 2, what's number 2 got that number 1 didn't? Okay, a -2 out front. What's that going to do to the graph? The negative will flip it, yes. Depends on which way you say that, but we'd rather say it's outside, so it's doing the up and down thing. So which way is it doing? Is it doing it this way, or is it stretching it or compressing it? Stretching. There's a 2 out front, so this is going to be a stretch. And how we use that, I'll show you in a minute. Stretch by 2. So again, we know what it does, we just haven't done the precision of that yet. So we know it's getting stretched, and we'll worry about exactly how to do that in a minute. Let's see. Oh, I guess we can let Layla take credit for the flip as well, because she saw the negative. Thank you. Ava, what else has happened in our...
It's moving left or left.
Which one? Remember, if it's in there with x, it does an x thing. X is the left-right variable.
Okay, so it's moving left.
So it's going to be left 1. And then, Corinna, how about that +2 at the end? What's that do?
It's going to go up 2.
Up 2. Okay, so left 1, up 2. So there's our vertex. Oh, which reminds me, I forgot to answer all the questions on number 1. But let's finish number 2, and then we'll go back and answer the questions. So left 1, up 2, flipped and stretched.
It went right.
Did you go right?
Yeah.
I did go right 1. Said left 1, and then I graphed right 1. I think my brain was trying to put the graph in the middle, but left 1. Gotta do the thing where you hold up the left 1. Okay, the stretch by 2. So normally from there we go 1, 1, 2, 4. If we want to accomplish a vertical stretch, which coordinate should we adjust? The x or the y? If we want to do something in this direction, the y. So this stretch by 2, we're going to multiply the y coordinates by 2. So we already knew it was stretched. Now we're talking the details of how to stretch it. Well, if there's a 2, let's multiply the y's by 2. Not the x's, because if you multiply the x's, then you'd have a left-right stretch. We don't want that. We want a y direction stretch. So now I'm going to go over 1 on each side and down 2. over 1 on each side and down 2.
Do we have to show that?
Yes. Yes, I'm glad you asked that. So I want to see basically 5 points per parabola. The vertex and then the 1, 1, 2, 4 points.
Do we have to label the vertex as well?
Well, this question asked me to list it, so yes. I just haven't done it yet. I mean, if you want to, you don't have to label it on the graph, but if it helps you to see, then it's certainly okay to label that with a V. And then back from the vertex, I need to go over 2 and down 8. So 1, 2, and then down 8. 1, 2, 3, 4, 5, 6, 7, 8. And because it's symmetric, usually you don't have to count off the other side. You just make it symmetric on the other side.
This rule, isn't it down further?
Yeah.
Did I?
You did on 6, not 8.
Oh, because this is from the vertex. These are not ordered pairs. These are directions from the vertex. So I already accounted for the left 1 up 2 business. So I can always use 1, 1, 2, 4 because I'm counting from the vertex. So from the vertex, I went over 2 and down 8. Now let's go back and answer those questions we were supposed to answer. We're on number 2, so let's stick with number 2. The domain, George, what's the domain of this graph?
-2 to 0, or no? Domain.
Domain. So that's which variable goes with domain?
X.
X. So how far left and right does this thing go?
-3 and 1.
Those are the farthest points we put on there, but the graph keeps going. There you go. Negative infinity to infinity. Forever left and forever right. Right. Range. There was a problem kind of like this on the test last week. Aiden, what's the range of this graph? Good. For range, for all of these, you have to put the smallest number first and then the biggest number. So for range, you'll go from bottom to top. So you can't put 2 to negative infinity. That's kind of what your brain looks at. It's like, oh, it starts at 2 and goes down. But when you write it, you have to write the smallest number to the biggest number. So you have to put negative infinity to 2.
Would it not be bracket 2?
And it would be bracket 2. Because we want to include the 2. Domain, range, vertex. So we already found the vertex. We just need to label the vertex or say what point that is. Well, that left 1 up 2 means, well, we can even color code this. How about that? -1, 2. Put vertex, because we went left 1 and up 2. And then lastly, the axis of symmetry. Well, it's easy to draw, right? It's just the line that cuts the parabola in half. And so that's x equals -1. All right, let's back up to number 1 and see if you can answer domain, range, vertex, and we'll be lazy and just say AOS, axis of symmetry.
So where'd you put the axis of symmetry for range?
So we can see where the line is. That's easy to spot. And then we know that an up and down line is x equals, and it's x equals -1. So now try those same 4 things about number 1. Domain, range, vertex, axis of symmetry. Good. What do we think the domain is going to be for all the parabolas? Negative infinity to infinity. Like it goes forever left and right. So that's an easy question every time. Haley, how about the range? Sure. I'll ask you a slightly different question. Which variable goes with range? It's the y's. So how far down does it go to how far up does it go? Well, be careful, it goes up to -2, so that needs to be our final point. Good. Negative infinity up to -2. Emery, how about the vertex? 2, -2, because we went right 2, down 2. And Scarlett, the axis of symmetry? Yep, x equals 2. Okay, so graphing parabolas, you've kind of done these. You have done these. The extra stuff today is the 1, 1, 2, 4 thing. So we're getting a little more precision on our graph. Well, how many more do we need to do? Why don't you try number 3? No, let's do number 3 together. Let's keep working together here. So I think I see 4 transformations on number 3. So Ocean, what's one of the transformations that you see? Stretch by 2. Stretch by 2. Fernando, what else do you see?
It's flipped.
It is flipped. Mateo, what else has happened?
Left 4.
Left 4. And Mason, what's left?
4. What's left?
I'm sorry, not what's left. Left is 4. What other transformation do we have to do? Up 1. Okay, so left 4, up 1. There's my vertex. And normally I would go 1, 1, 2, 4 from that point. But this one's a little different, so Eli, how do I figure out where my other points are? Perfect answer. We're going to multiply the y values by 2. And you know what? On this one, I'm going to multiply the y values by -2. Do you know why? Anybody know why I would want to do that? It's flipped. So you don't have to include the negative. You already said it's flipped, so you should know it's flipped. But if you include the -2, that will maybe remind you to flip it. So you don't have to multiply by the negative because we already said it's flipped. But you definitely have to multiply by the 2. So again, from the vertex, over 1, down 2, over 1, down 2. Again, be careful. Those are not ordered pairs. That's why I don't put them in parentheses, because I don't want to get confused. They're more like ordered directions from the vertex. Over 2, down 8. 2, 4, 6. 1, 2, 3, 4, 5, 6, 7, 8. And again, on the second one, I don't really count. I just mirror it over there. Sketch in the picture. Domain, range, vertex, axis of symmetry. I think we're all experts now, so you don't need much time to think about these, I hope. Audrey, how about the domain? Yep. Max the range. Good. Angelina, the vertex. Oh, yes, sorry. So she pointed to say left 4 and up 1. I'm going to assume that's what she said. Is it this month or this week? Is it this whole month is deaf awareness? Is it the month or the week? I don't know which one. Is it the month? The month. Okay. So she's participating in that, so she's not talking to kind of get the experience of what it's like. So that's why she's not talking over there. So I keep asking her questions and she can't answer. Samantha, how about the axis of symmetry? I'm glad you said that, because that's not quite right. It needs to be x equals. Negative 4 is just a number. I want the line x equals negative 4. Okay. That's kind of it. Like, they're all parabolas. You already know transformation, so you're pretty good at that. The only new thing today is the 1, 1, 2, 4, and then multiply it if there's a stretch factor to think about. So it looks like a lot of problems, but they're going to go quick because you know this stuff pretty well. I'm trying to see if there's anything else that looks weird. Flip over to 13. Why would I pick 13, do you think?
This is a fraction.
There's a 1/2. What's that do to the graph?
Compress it.
Compress it. Everything is this way, though, not this way. I'm going to compress it this way. So what do you think we're going to do with that 1/2? And what part of 1, 1, 2, 4 will we multiply by 1/2? Only the y's, because we want to accomplish a vertical squish. But other than that, it's kind of the same thing. Left 4 up 2. Apply the squish. Let's see, left 4 up 2. Another one where the scale is weird, 1/2 rather than 1. Left 4 up 2. And then instead of 1, 1, I'm going to go over 1 up 1/2. Over 1 up 1/2. Over 2 up 2. And so that's a wider parabola, but it's wider because it got squished. And then answer all the questions, domain, range, vertex, and axis of symmetry. And then there's some more factoring problems on the back, because we still need to practice factoring. You know what? I'll tell you what. Let's save the factoring problems. That'll be tomorrow's assignment. Because tomorrow's going to be a lot of notes, but not a lot of homework. The only new homework tomorrow is going to be those factoring questions. So, sorry, adjusting things on the fly. So, through number 18 for today. And then the back of that worksheet, that'll be Tuesdays. Nothing new on that factoring, that's just more practice. So today, just the graphs. Unless you got extra time and you want to knock out the factoring, whatever. This is still due on Friday, so make sure you're keeping up. This is my attempt to keep you in line and keep you kept up. There were so many zeros last time, that's why some of the test grades were what they were. So kind of revert back to taking up stuff a little more often to help some of you out, help manage your time for you. But yeah, today's not bad. Just 1, 1, 2, 4.